Can I hear okay in the garage in Melbourne?
Talk to each other.
There you go.
Yeah, cool. So, yeah, I guess the definition of an app has changed, right? So, you know, modern enterprises that we talk to or that talk to us, they're very much sort of developing or, you know, rolling out to production what we call like heterogeneous applications, right? Now, historically, what we tended to see was things like this, and I think that's probably all familiar to you guys, right? It's sort of like largely a cluster of something, which is represented by like several VMs. Application might have like, you know, maybe fairly monolithic, might be a couple of VMs, might be like many VMs, might have some sort of presentation or web tier, some sort of application middleware tier, and more often than not, some sort of back-end state database persistence tier and that sort of thing, right? So this is a pretty familiar picture, right? Could be VMs, could be bare metal, could be other things as well, right? But what we tended to see with this sort of stuff was it traditionally lended itself to more like monolithic architecture, you know, some really tightly coupled stuff. So maybe a lot of the interactions within the app are happening internal to the stack or to the VM. You know, we typically saw like long development cycles, you know, very like infrequent change and stuff like that. You know, typically it was like a single environment. There wasn't much promotion happening across, and you know, again, sort of slow to scale, right? You know, typically the scaling activity for these types of things would be like vertically, and let's add something to it, more RAM, more CPU, something like that, more disk, right? As opposed to like linearly scaling or horizontally scaling. Yeah. So where we move to today, or a lot of the discussions I have, are in enterprises where applications look a little bit more like this, right? And they're sort of a little bit more like distributed in nature. So you can see like, you know, a couple of boxes here that represent components that, you know, applications tend to comprise of. So Kubernetes cluster, right? So Kubernetes is essentially becoming almost de facto standard for like maybe IaaS API surfaces and infrastructure provisioning and that sort of stuff to host modern apps. So you can see here that maybe there's a customer with a kube cluster, right? They might even have something like a serverless framework, or maybe have some functions within their application, right? So maybe it's an event-driven application, maybe it's e-commerce, maybe it's some sort of like, you know, IoT type application, whatever it may be that requires like a lot of eventing. So maybe serverless is something that forms part of that application, that modern stack. Then we have things like specialized applications, right? So this maybe is something that you might have a small cluster or a couple of nodes that are running things like GPUs, right? For application acceleration or for things like data science, machine learning, and that sort of thing, right? So, you know, what I'm trying to get you to understand here is that modern apps are a little bit more distributed. They're probably comprised of various different types of components. And, you know, our job as like engineers is to try to help people understand how that sort of couples together and how they can sort of make it a little bit more, you know, future-proof and stuff like that, get benefits out of it. Of course, you're always going to have some state somewhere, whether it's user or data and that sort of stuff. So those layers still exist, but the way that we approach it and the way that we attach it is somewhat different, right? We might be doing things like, you know, automatic stuff. We might do like dynamic binding activity and stuff like that, which again is very cloud native, but that's what we're seeing. So talking about cloud native, you know, there's a foundation that provides like a bit of assistance and a whole heap of upstream, what we call upstream projects, right? That, you know, in theory help customers understand and, you know, get better at doing these types of modern apps. You see there's a bit of a definition. It's about like scalable apps running in modern dynamic environments, yada, 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 using things like containers, microservices, APIs, and really like declarative type activities, yeah, versus imperative activities. You know, when you start taking advantage of these stacks, you see things like, you know, real on-demand delivery, right? And you enable things like self-service capabilities. You see like global deployments, right? Multi-AZ, multi-region, that sort of stuff, right? And you see elasticity, right? Both like horizontally and sort of cross-site and that sort of thing. And you get the advantage of you can take advantage of higher value services, right? So it might be, like I said, a dynamic bind to a database or a caching service or something like that, right? And, you know, improvements are many, but like here's a couple, right? Productivity is important, especially for the developers, because, you know, they're essentially like the value creators for the organization. They're the ones that are writing the code that creates the money for the business or the revenue for the business, right? Agility from a business perspective, stay competitive, get even more competitive in market. Scalability, we've talked briefly on. Availability, right? Uptime's important. You know, we don't want bad minutes, we don't want outages, so cloud native helps with that sort of thing. So you can see other benefits there with regards to cost as well, right? So this thing here is something like a framework. So we talk to customers about like, starting to develop their application architecture to be 12-factor, right? You may have seen this before, you may not. I'm not going to talk through each of these things. Just be aware that there's something called the 12-factor application, and 12factor.net is the URL, the website. You can go and have a look, and it articulates like what each of these things means, right? And then you can sort of understand, well, we do that a little bit, or maybe we need to start doing that. So it's just about like getting more consistent with the way you do environments. Parity is very important. Consistency is very important, right? Things like the way you treat backing services, the way you treat things like logging and authentication, those sort of things. So if you're doing these types of apps, then I encourage you to go and have a bit of a sticky beat there, right? But of course, even though they're modern and we're doing them in cool things like maybe containers and Kubernetes, there's still challenges, right? So there is a lot of complexity in this ecosystem. There's a lot of friction still that exists in the path to production, right? And there's a steep learning curve, not only with containers and Kubernetes, but like periphery activity as well. So that's primarily on the dev side. What about on the sec side, right? So if we talk about open source software, which a lot of companies are consuming today, we see vulnerabilities there, right? Some are, low sort of critical vulnerabilities, but some are very critical, right? And they need to be remediated. So that's a challenge. We're seeing like bigger attack surfaces because of the environments that we're creating in the cloud native space. So people are getting compromised in different types of ways. And then we want to make sure that we're seeing like, protecting things like code and images and containers and that sort of stuff as we move through into production. So that's sec side. And then obviously ops, similar things, right? You want to be able to see stuff. Visibility is important. Control is important, right? Security controls and that sort of stuff. Automation, very important. You want to be declarative and that sort of thing. And then protection of the data, right? So I sort of did that on purpose because, this DevSecOps movement is becoming a bit of a thing, right? And when we talk to customers about DevSecOps, we talk about shifting left and governing right. So try and get like security as close to the developer or to the code as possible, right? But then govern right through a supply chain and stuff like that. So just a couple of concepts there to digest. Sing out anywhere that you've got questions. I'll take questions. Cool. So containers are not new, or the idea of containers is not new. So if we boil it really, really down, containers is just like process isolation, right? So you can see as early as like 79, we had process isolation. I think mainframes even had process isolation. So as you go through the years, like, up until sort of 2011, 2010, 11, this is where we started to see companies taking advantage of some of the low-level Linux kernel primitives, right? And conceptualizing, well, if I wrap some of these capabilities of Linux in the kernel, maybe I can make it easier for people to take advantage of this type of stuff, right? So that's what happened with Docker. So Docker the company, Docker the project, Docker the upstream company, all that sort of stuff. They basically pioneered the containerized application model. Now that was 2013, so that's a little while ago now. And you're starting to see like, adoption sort of only now, up until now. It's not been high, but, maturity, there is maturity in this space, but there's a lot of customers that are still not taking advantage of it.
Can I just ask, we're all chatting, who's running containerized applications in productions in their business? Anyone? Not yet.
Yeah.
Who has a container environment in their business, whether it's for production or non-production or whatever?
Even if it's just hosting a Quake server. How do I know you put your hand up for that one, Bob?
Special. So is anyone seeing vendors sort of releasing container images rather than, deploy a VM and install it on that now? Is
Yeah, we've got a Tufan image right now running.
So I think from my side, when we first sort of heard about Kubernetes and VMware moving that direction, it was like, oh yeah, that's not going to happen for a little while yet. But even now, customers who I would think would ask us about that have, started to say, oh, this particular vendor has now given me an image, this Docker image. How do I run that on my VMware environment? And oh, well, you can't run it directly on it unless you do this and that. But it's starting to become more and more of a common thing. And I think that's what Jamie's talking about. Like, it's been around for ages. It's only now that all of us are kind of having to deal with running those types of environments.
I think actually the ISV-driven, so the commercial off-the-shelf software is the fastest growing piece of the market in my customer base. When I speak to the large enterprise customers I look after, from a VMware perspective, it's ISVs coming to them and saying, this new piece of innovative software, we only deliver it in a container.
Okay.
Yeah, and you'll see, I have to find that as probably the most common use case.
Can I ask why you reckon they are doing that? Why are they shipping container?
You think about like they've got a business to run, they've got revenue to make, they've got things they want to introduce into their architectures in terms of the software they deliver to their customers, right? So if they can take advantage of some of these characteristics, then they're going to do that, right? So it is a very common use case where it might be airports and things like gating systems or card access systems or pushbacks for airplanes and stuff like that. All the vendors are sort of saying, well, if you want to upgrade to version blah, blah, the new version, we'll deliver it to you in containers, right? So then the customer comes and says, well, we don't really have any experience in containers and we don't really have a platform to host this new type of workload, but we actually want to upgrade because we've got some issues. So, that's sort of problem number one. And it's a very big use case, right? Also things in telco, right? Telcos are moving from what they call VNFs, like virtual network functions, VM-based if you like, to CNFs, container network functions. So you're starting to see telcos deploy, edge type workloads or core type workloads or IMS or any of the OSS, BSS stuff that you traditionally see like big and ugly. They're doing it in more like modern ways, right? So the Ericssons, the Nokias, the Huaweis, they're starting to deliver containers to the telcos and stuff.
I don't want to steer the conversation elsewhere, but I mean, it seems to me that containers is still quite a narrow field. You've mentioned before that, commercialization for websites, reiteration of things like that, or IoT. I have no need for that at all. I'm just a stock standard business running, Windows.
Sure. Yeah.
So if it opened up in that realm, then yeah, why not?
Yeah. So, it used to be like a couple of years ago, if it runs in Linux today, it would run in a container tomorrow. That is no longer the case and hasn't been for a couple of years. So Windows containers are a thing, right? We have 2 or 3 different ways to run Windows containers. You can do it natively, 2019 and stuff like that, or we can show you how you do it. So, don't think just because you're not like a Linux environment or you don't have a need or you can't spin containers, right? So you can definitely spin containers.
If you're not doing Devops and writing your own code base,
yes,
you're going to impact the applications. Probably the payback for the business is not there.
Yeah,
so I want availability, consistency. I'm not doing iteration of the code over days and weeks and years.
Yeah, I mean, obviously all this sort of stuff is like outcome based or outcome realization, right? So if you don't have a genuine need or a defined use case or whatever, like the COTS thing, then yeah, exactly. I agree 100%. But unfortunately, there is a lot of, vendor movement around like distributing in containers. So if you are using COTS, maybe it's around the corner, and then you want to think about, okay, how do we host it, right? Because the vendor will obviously mention software, but they want the platform. You can manage service capabilities, maybe you won't, maybe you need to do it yourself. So yeah, we see it like small scale, but we also see it like large scale. It might just be one app or an app that represents heaps of estate or heaps of infrastructure. So yeah, I agree. Use case dependent.
What's coming through as a feature of electric cars, right?
Yeah, exactly. Yeah, no, you're right. Yeah.
That's the thing as well. Like, so I've got a customer. I can't say who it is, obviously, because it's confidential to their business what they're doing. But they're developing this service based on a couple of different applications from a couple of different vendors. So it's like a bundle. I'm trying to think of a way to say it without giving away too much information. But it's basically half this application is about 250 workloads. Half of it's going to be VM based, so standard, like, deploy me a Windows whatever version VM and put this on it. And the other half, because there's sort of 5 or 6 vendors in this solution, they just give you container images. They won't let you deploy it on a VM. It's basically like, no, here's your Docker image, off you go. So they're a traditional VMware shop, and they've been faced with this problem. Now we really want this, this solution, but half of it's going to be container images. What the hell do I do with that? So it's been a steep learning curve for me, where customers actually got this problem where they're saying they're just a Windows and Linux shop. They just host VMs for their their users basically. And now, because this is pivotal to the business, I shouldn't use that word, this is critical to the business, they've come to us and said, how the hell do we run these containers on all this infrastructure we've already got here? So that's been an interesting learning curve, but yeah, exactly what you're saying with, while we've sort of, I wouldn't say ignored it for a long time, we've never really seen it impact us for a long time until now. Now I'm starting to see a whole bunch of my customers who most of the time are a little bit behind the times, a little bit slow to change. They're all sort of saying, we've got a requirement now, we need to do something quick. We don't know how to do it. So
yeah, I mean, this is the obligatory sort of stats and it's always the same types of companies. I don't want to draw your attention to the actual company. I wanted to draw your attention to some, like, the scale, right? So let's just focus on this bottom one, right? So Google has maybe 7 lines of business, maybe more. Each has like over 1 billion subscribers, users like that. So you can see here, like they're spinning like over 2 billion containers a week, right? So every second, every minute of every hour, every day, they're spinning 3,500 containers. Now, if you've ever used Google Cloud, right? If you've ever asked for a VM in Google Cloud or in Azure Cloud or etc., like 99% chance, definitely in Google, but in others as well, that's spawned in a container, right? So they're giving you an EC2 instance or an Azure instance or a Google instance in a container, right? So everything that's runs in Google for the last, since 2013, basically spawns in a container, right? So you might see containers popping up in spots you didn't believe containers existed, right? They might be hidden, they might be abstracted, whatever it may be, but just be aware that they are sort of everywhere. I wanted to just give you like an indication. I mean, I wasn't sure. I made some assumptions about like who maybe had used containers and that sort of thing. So I just wanted to give you like some level set stuff, right? So simplest form, like think about a container as like a box for all my app things, right? It's as simple as that. It's like a packaging format for software, right? So what could be in that box, like for the software, right? Because it could be binaries and libraries, just executable. It could be dependencies that the app needs, right? Or it could be or will be the actual code and the application. So if you looked at a really typical sort of, let's say, Java application that runs in a container, it's going to have a base OS still. It's going to have a Linux or something like that. Then it's going to have some packages that maybe your platform or your infra, your ops team is going to add into it, right? Then it's going to have a runtime environment, Java or JRE. It'll have things like Tomcat. Maybe it's hosting a web service or surfacing a web service. And then it's going to have the dependencies in the jar for Java and the configuration, right? Now, all gets packaged up quite neatly, and the ability for us to take that package now and distribute it like where we want to distribute it to. So it's quite portable, right? That's what I'm trying to get at. So it's a packaging format that enables portability, right? Across environments, right? Across clusters, across clouds, across environments. That sort of stuff. Now, underneath, I won't talk about these much at all, but this is where I said that, containers make use of some of the Linux kernel primitives and Windows primitives as well, right? So things like namespaces, all that does is gives you isolation. So it's like a soft boundary for isolation between the containers, yeah? C groups is what's controlling resource allocation. So a container makes a request for a resource, mem, CPU, IO, disk, whatever. C groups is going to sort of govern that, right? And it's a file system, right? If I showed you inside a container, it's basically a layered file system. It's called Union File System. Works on copy on write. It's like a snapshotting technology for those who are like familiar with storage and snapshots at a storage level. Similar thing. Bottom few layers are read only, top layers are read write one. It enables change, that sort of stuff, right? And then SE Linux is just for security, right? I can get more like, I can introduce more rigor around what's happening at a Linux syscall or Windows syscall type. Now, if I said to it like, maybe as a developer, like how would I start to go about thinking, how would I create a Docker container, right? So it could be as simple as like 2 or 3 lines. This one's 4. I'm just saying, give me Ubuntu as a base image, copy in my application, make is like a build for the app. So just build it. And then the command for the container as an entry point is Python, right? So this is a Python app. Now, if I was going to do it in Docker, I would build it. So I'll build my Python app. Then I would run it, right? Then I could see it running. I could log it, and then I could stop it. Right now, containers are ephemeral by nature. What that means is they go away at any time, right? I'm not sure if you've had this pets versus cattle analogy. VMs are like pets. You give them names, you feed them, you water them, you take care of them. They live a long time, all that sort of stuff. Containers are more like cattle, right? Cow falls over in the back paddock, go into the stockyard and buy a new cow. So they're ephemeral, they don't have names, that sort of stuff. Now, if you want to talk about serverless, then that's the virus, it just spreads everywhere. So that's sort of what it looks like. If you package it up, it looks like that. Layers, as I said, bottom few layers are read-only, right? But the top layers are read-write layer. So if I add something to the container, I shouldn't, but if I did, it would just add a layer on top. Every one of these entries here, these lines, if you like, represents a layer. Simple as that. If I added another layer, another command in here, another layer would appear in here. Okay, so what are some of the benefits, right? Isolation, we just talked about isolation through namespaces. It shares a kernel at a lower level, shares the kernel. So I'm getting like some efficiencies there, right? It's small, there's no bloatware. I don't get like big 4 gig, 8 gig, 10 gig images. I get, 2K images, 10 meg images, 100 meg images. Very, very small, very, very fast, very, very agile, right? So density is good from a TCO perspective on my infrastructure. Yeah. Deployment and scaling, very easy. Yeah, single line commands to deploy, single line commands to scale. I can programmatically do it, or I can imperatively do it at the command line. Portability, talked a bit about that before. So I build once, maybe it lives in a registry, which is sort of analogous to a file system, if you like. Container lives in registry. I can deploy that container many, many times to many, many different locations. And consistency or parity across environments. So a developer who works in dev, then the platform team or the ops team is promoted to pre-prod, for instance, and then to prod. I'm sort of getting parity. I know what I'm going to get. There's none of this like worked on my laptop type problem that is historical. So the Docker promise is essentially this, right? Build, ship, run. That was their messaging like way back. Still pretty common, right? So the build is the Docker file, which you saw. The shipping is the image, as I said, you can ship it many places, and the run is the actual container. So a container is just a running image. Now I can show you potentially what that looks like, or we can just crack on. How are we going for time then?
Quarter to.
Pretty good. So let's just have a look. So for instance, I've got Docker running on my laptop, right? Obviously you need Docker as a runtime to accept workloads. Okay, cool. No biggie there. What about if I said, okay, go out and fetch an image for me? So I'm just asking the Docker daemon, which is my laptop essentially, to go and pull an image from Docker Hub, which is an internet-based registry. Doesn't have to be, could be behind my firewall, could be a private registry, right? Oh yeah, good start. Let's just go, let's see if I already built, had it before. Oh, I'm already drunk. Oh my God. What am I doing wrong here, Pat?
Did you make
sacrifices
for the demo god?
Did I what? Sorry.
Make sacrifices for the demo god?
I know. I obviously did not. And I'm just copying it from here as well. So there's no excuse. If it works, I'll show you what I'm trying to do. I mean, has anyone actually sat at their laptop and had a go at Docker? I know there was a few hands that gone up before. To be honest, I don't spend a lot of time interacting.
I've got Pi-hole running as a Docker image on my Synology.
Yeah, sweet. Okay. So what I did there was I say, yeah, in theory, I would have pulled the image down, right? And then I can build the image, right? So I just say Docker build that image essentially, or I refer to the Docker file, which is those 4 lines I showed you before, pretty easy, right? And then I just run it, right? So what I've said here is I've just said, Docker, run it for me, make it interactive. That's the name of it. And I just passed in a message, right? And it spat back the message. So if I was to say, is it running now? No, it's not running now, right? Because they're ephemeral. It's already exited. After it said welcome VMUGers, it exited, right? So it's quite good for like, maybe just like sporadic type, workloads. Maybe it's a batch, or maybe it's a cron or something like that. Whatever maybe it's a task you need to run in your infrastructure. Maybe it's a logging thing, an auth thing, or a reporting thing, or something like that. Of that, you can sort of do it in containers, and it's makes sense to do so, right? So there's not really a lot more to see. I mean, you can actually console, you can exec into containers. So don't think that they're like locked and you can't see inside them. You can go inside them. If you go inside them and you just do ls, you'll see a file system. If you see df, you'll see like mounts, disk mounts. So it just sort of acts like a Linux machine, right? But it's sharing the underlying kernel. The other good thing is you can actually enter the container after it stopped running, which is a little strange, but you can do so. If you need to go back and revisit, understand, troubleshoot, log, whatever like that, you can do this. Okay, so then, we've got we sort of understand a little bit about containers. We've understood, okay, maybe we can use containers in a certain way. But, what's Kubernetes and why do we need Kubernetes, right? So Kubernetes is often referred to as a container orchestrator. Primarily, it's like if you've got 1 container, 3 containers, 10 containers, maybe you're able to manage them pretty easily. Like maybe it's a COTS app, like we've said. Okay, I can do that, right? But maybe my business has decided to do something that's a little bit net new in terms of app dev, or maybe we've made an acquisition or an M&A or something like that. So we're scaling and now we've got containers. So there's containers everywhere. So now I need a container orchestrator, right? Because it's doing some things for me that I couldn't do before with just straight containers, right? Now, if we look at some of the other things that I can do, or that I should be able to do at Kubernetes, I might have a challenge to understand where's my web server. How do I actually understand where that container is? Like Bob deployed it last week. I'm not sure if it's still running or even which node it is or where it exists, right? So orchestrators can help me understand that sort of stuff, right? They can help me understand how they can facilitate the sort of linkage between the app or the web and the database, right? They'll do that for me. I don't have to do silly things like hard coding IPs and that sort of stuff, right? Maybe I need to upgrade a set of containers. I don't want to do that manually. I don't want to create a new Docker file and rebuild and all that sort of stuff. So Kubernetes can help me actually do things called rolling updates. So one goes down, one comes up, down, one comes up. So it's actually very minimal. There's no downtime involved, right? So it facilitates that for me. And then basically any other thing like management lifecycle, patching, self-healing, scaling activity, Kubernetes will facilitate that for me, right? So these are some of the popular ones that you may have heard, right? Docker Swarm. So a lot of people use Docker Swarm, and that's okay. When the environment starts to get a little bit bigger, maybe they need to use something else. HashiCorp has one called Nomad. Okay, very good. There's Mesospheres, existed for a long time, right? Okay, cool. And then there's Kubernetes. So little hint is that Kubernetes is winning, or pretty much won, right? It's pretty much the de facto standard when you talk about container orchestration.
It's owned by Google.
Yeah, it largely it came out of Google. You're right, yeah. And three of the sort of guys that were involved, well, two of the guys were here for a while, VMware. One's at Microsoft, and the other one hasn't been seen since. But but yeah. So what is Kubernetes? Okay, it's primarily a container orchestrator, right? It's highly extensible. So don't think that just because you're running Kubernetes or you've decided to deploy Kubernetes that the fun stops there. It does not. It's a complicated platform, a complicated capability, a complicated set of components that you need to manage and extend in order to make your environment successful. Now, don't let that scare anyone off, because we can help with some of those things, right? And there's many things out there that will help you, right? But just as an example, what sort of things can Kubernetes do for me or my organization? Cool, I can start 5 containers. I can start 25 containers. I could put a load balancer in front of those containers with Kubernetes, dynamically, automatically, right? I could scale. What if I'm responding to an event or to peak traffic event or Black Friday or Christmas or Easter, whatever it is, right? Maybe I'm an e-commerce business or something like that. Kubernetes can handle the load for me or dynamically. You can scale via things like horizontal pod auto scaling or vertical scaling activities or even cluster scale activities, right? So it does those sort of things really, really well, right? New release of something, it'll roll it out for me, okay? And that's pretty straightforward stuff. But what if, we want to level up? What if we got really clever and wanted to do things like blue-green? Add a new button to a website, test a bit with users, see if that's going to be something we roll to production. Kubernetes can facilitate that type of rollout strategy, right? You can have long-running services or even batch jobs. You can sort of do batchy things with Kubernetes. You can overcommit resources. Kubernetes is smart enough to go and actually start evicting some of the pods, some of the containers, if you like, that it doesn't really think is active at the moment. So it's quite a clever sort of orchestration system. You can do RBAC, control, you can integrate stuff, you can extend stuff, you can automate stuff. It's really good at those types of things. And it's got self-healing capabilities, which is really cool. So straight away, benefits is resource utilization. It's got very intelligent scheduling, right? There's a term called bin packing. So Kubernetes really understands how to fit all those containers or those pods into the nodes that you're surfacing for the cluster. It's very good at doing that, right? So density is good, resource utilization is good. There's shorter dev cycles if you've got teams of devs that are working against it. It's really fast to do that sort of stuff. Really easy upgrades. Maintenance becomes a little bit easier as well, right? Patching, lifecycle, that sort of stuff. You can start to containerize the old stuff, the ugly stuff, the monolithic stuff. And maybe it enables a move to cloud. Maybe your organization said, we need to go to cloud in 2 years' time. So maybe containerization is a step for that, because we've talked about maybe portability is a benefit of this sort of thing. So if I went to containers maybe now, in 2 years' time, I'd just redirect those containers or port them, so to speak. And again, just an example, big companies, it doesn't really matter, but scale is not a problem, right? These Mercedes is running over 900 clusters on premises, right? Nordstrom talks about speed. They talk about operational efficiency. they talk about the fact that if they were to move the workloads, or they tried to move workloads to AWS, it would have been like 2,600 VMs. But they moved to containers, it actually was 40 VMs, 2,600 container pods, right? So they got like really, really good financial benefits, really, really good operational benefits, because they're using the same skills, experience, tooling that their staff have, because they're familiar with vSphere, or they're familiar with on-premise infrastructure. They didn't have to go and, adopt cloud, learn cloud, manage cloud, that sort of stuff. I was going to go just to give you some high-level, the components. Maybe we'll gloss over some of that. I sort of already said it's quite hard, right? So one time I tried to explain Kubernetes. Okay, let's do some fun facts instead, right? So it came out of Google. So you point at the back there. Google has an internal container orchestrator called Borg. So there was Amiga, there was Borg, and there was Kubernetes. So it surfaced publicly around 2015. Interesting fact is that, if you look at Borg and Bosch, so Bosch is a substrate. So has anyone heard of Cloud Foundry? Platform as a service, Cloud Foundry, that's okay. So underneath Cloud Foundry is Bosch. Now, if you look at Borg, B-O-R-G, and you look at Bosch, B-O-S-H, you progress the R and the G to the S and the H, right? You get Bosch. Now, interestingly, the dudes who were at Google, the tech director, primarily Derek Collison, came to VMware and actually formed a team who wrote Cloud Foundry. So very similar conceptually on how to do infrastructure scale, self-healing, HA, all that sort of stuff, right? It was going to be called 7 of 9 because the dudes were very, Trekkies, right? And in Star Trek Voyager, one of the Borg drones was 7 of 9, right? So it's going to be called 7 of 9. Now, this is a word I've not heard before, but apparently it's a numeronym, right? Does anyone know what a numeronym?
I was just about to explain it.
So Kubernetes in the market is often referred to as Kates or K8S, right? So if you look at the letters in Kubernetes, between the K and the S, there are 8 letters. So it's a numeronym. There you go. Never knew that before. There are other examples which I didn't include here, but Kubernetes is one of them. Some just very high level stuff, right? Most Kubernetes clusters are comprised of 2 different types of nodes. There are master nodes, which is the control plane. There are worker nodes, which is essentially the data plane. The master nodes or the control plane holds several components like an API server, a scheduler to do those intelligent things, some controllers, which are like loops, if you like. They're watching, they're observing, and every time you declare something, it'll try and reconcile to get to that declared state. There's a database, it's called etcd in this instance. That is the state store. Whenever you push an object, push a deployment, push a service to Kubernetes, it hits the API server and the state is stored in the database. Quite simple, right? Now, at a worker level or the data plane level, there's a thing called a kubelet. That's like the brain of the worker node, essentially. It's responsible to talk back to the API server, understand instructions, receive instructions, and execute on instructions. Okay, fair enough. There's a container runtime. Obviously, to run a container, we need to have a runtime. Right? It just catches the container and spawns it as a pod. I've said pod a couple of times. Pod might not be familiar. A pod is defined as 1 or more containers. It's just a unit of deployment. And there's a kube proxy. The proxy just takes care of things like network routing and stuff like that. So IP tables, IPVS, pretty straightforward. In terms of inner workings for Kubernetes, these are 2 concepts that's worth understanding, right? So I just sort of talked about control loops and reconciliation. This is what's happening constantly within Kubernetes, right? So I declare, or I sort of have a desired state, and I declare that via configuration. Kubernetes does the best job it can do to make that an observed state, right? It just loops around. Every time something doesn't look right, it tries to change it, and it tries to reconcile it. Now, the analogy I use here is like a thermostat, right? So air conditioner at a home, you say, I want the temperature to be 20 degrees. The thermostat says, oh, the temperature thinks it's 17 degrees, but it's got to try to get to that 20 degrees, right? Your desired state. So Kubernetes is working like that. It's a finite state machine based on reconciliation loops. The other important thing is this notion of imperative versus declarative. So imperative is where I'm basically, heavily articulating what I want to do, right? I want to get, delete, create something, right? Whereas declarative is, which is the way you should be moving towards, is where I say, here's a YAML file, or here's a text file, if you like, which has some things in it that I've declared that I want you to execute for me. So that's more about declarative. Now, this is actually a real roundabout in the UK somewhere. So when I think about like,
it's the magic. There's the magic roundabout in Swindon.
yeah, exactly. Yeah.
Brilliant fun to drive over. You literally start one side, just aim straight for the centre of the
Yeah, it's fun me out when I saw it. I saw a video of it as well, and it was just like, I just don't understand. But if you think about like when I think about Kubernetes, because there's not just one controller, there are multiple controllers. So they're all looping and they're all trying to reconcile and they're all responsible for various activities. I just think about this roundabout. So, it is complex, but, very rarely we'll have to, interact with the controller level, right? Cool. So that was my attempt at trying to level set you, right? So, you heard a bit about modern apps, you heard a bit about containers, a bit about Kubernetes. So now, we've got the strategy memo, it's time to go, right? We need a platform for running containerized apps or COTS apps. We've talked about that already, right? The other big use case is that, we want to modernize our infrastructure or the platform because we're getting ready to, do hybrid cloud or we're trying to transition towards multi-cloud, right? So we want to have some consistency and some portability and that sort of thing, right? Or we hear a lot about organizations with dev teams are pushing the business really hard to have a platform where they can self-serve or where they can get a little bit more like productivity, efficiency through frictionless experiences, right? So they just want to write code, push code, and have a platform sort of take it and run it, right? So we're seeing a lot of that as a use case. And then the other one is we've been on this enterprise transformation from an app perspective for a long time, and we've given up. It's cost heaps of money, and we haven't got anywhere because it's analysis paralysis, all that sort of stuff. So we can come in and sort of say, well, we have some capabilities and some tools that enable you to actually do really quick discovery and actually do things like what we call V2C, which is like a VM to a container. We can do that sort of automatically. So we sort of help organizations understand that maybe there's a better way to do some of that transformation. Okay, cool. So the strategy memos come out. As a platform team or infrastructure ops group, you need to move to Kubernetes, right? So as I said before, it's hard. It is hard, right? And it's hard because these are some of the things that you need to think about. First instance, right? So Kubernetes being the middle, just look, these branches could go on and on and on and on. And it's not, again, meant to scare you off, but just be aware that there are a lot of decisions to make and there are a lot of projects that can help you, a lot of vendors that can help you, but you just need to be aware that there is a lot of considerations. And it doesn't end with that spaghetti junction. There's heaps of other things to consider. But, never fear. The CNCF provides the projects to help you understand and get there, right? Sure, okay. So what are you actually looking at there?
That's not even the full chart.
Yeah, I cut it off to fit it. So what you're looking at there is over over 1,000 cards. A card represents an upstream project, right? There's three and a bit million stars. A star is based on an upstream commit to GitHub, right? Projects get starred depending on how popular and stuff they are. So there's a lot of stars, a lot of projects. You look at the market cap of those 1,000 projects, right? $21 trillion, right? And the 51 billion represents funding that they've got from venture capitalists and angels and that sort of stuff. So there is a lot of activity. There's a lot of projects to choose from. It's important to make good decisions, and we can help you make those decisions. Now I'm sort of going to talk a little bit about the capability, but maybe I'll just show you. So this is vSphere, right? If you're a vSphere 7 customer, is anyone a vSphere 7 customer? Yeah, no worries, mate. vSphere 7 customers, anyone? Okay. Soon to be vSphere 7 customers on roadmap, uplift. Is there people in the room that are not using vSphere?
Get out.
There should be. Anyone on a pre-6.5 vSphere? 6.7?
Yeah, we've got 6.7, 7.
6.7 and 7. Okay.
You might want to think about upgrading fairly soon.
We like 6.7, it's nostalgic.
So good news for the one person in the room, you can have Kubernetes tomorrow, right? So vSphere 7 customers can enable Kubernetes in vSphere, right? And it's done by this thing called workload management. So back into 2019, early 2020, we actually spent a lot of time, we actually re-architected vSphere as a platform to be Kubernetes native, right? What does that mean? We added some stuff into ESX, just like we did with software-defined networking, software-defined storage, to actually be able to run containers or what we call pods natively on ESX. So I talked a little bit about that thing called a kubelet, which is like the brain of the worker nodes. Guess what? We mimic that behavior and we call it a spherelet. So that spherelet runs on ESX, so it can accept containers. You need a runtime. I remember I said we need a runtime to run the containers. Could be laptop, could be other. We added something called CRX. So again, I can push pods directly to ESX. So that's just a couple of things we did, right? So I've enabled that. I actually get a 60-day evaluation of Kubernetes, right? So I can go nuts, I can start spinning up clusters, I can push containers, I can show my business what the value may be, I can host a vendor workload, all those types of things, right? What does it give me if I enable that, right? So what it does is it spawns this thing called a supervisor cluster. So it's 3 VMs pop up, and they join as a cluster. Now that supervisor cluster holds certain capabilities that are exposed to people accessing the platform. You don't really interact with the supervisor cluster. You do have to upgrade it from time to time when we push a release, But otherwise, it just sort of sits there and exposes capabilities that you need to take advantage of. It exposes things like you can attach like vSM file services. You can do VDP or vSphere data persistence. So you can do object storage for containers, or you can do NFS storage for containers, all that sort of stuff, right? It also allows you to do magical things like if you get really good at writing YAML to do containers, in that same YAML or text file, if you like, I can declare a VM. And there's a VM operator that lives in the supervisor cluster that understands that text file and will spawn a VM. The other interesting thing that it gives you is this notion of a namespace. Now, I mentioned namespaces in Kubernetes. This namespace is not analogous to a Kubernetes namespace. What it represents is basically in vSphere language, it's a VApp and a resource pool collected together or put together. And it's sort of like a logical bucket. And in that logical bucket, I put stuff, right? And it allows me to define things like policy, storage policies, RBAC policies. This is where my clusters live. I can define capacity limits and all that sort of stuff. So you can see I've created a development namespace and I have like a Kubernetes cluster running in it. Right?
Just a quick question. For the admins, vSphere admins here, who would give the developers in your organization free rein over resources to build their own applications?
What could go wrong?
They did the right thing.
Yeah,
Yeah, exactly. There's enough people.
A developer given the ability to scale up a XXL sized resource is never going to use it, are they? They'll choose the smallest possible resource they can get away with.
Yeah. So once devs get into this container, it's like they love it, right? And they just keep pushing. What this namespace in vSphere allows you to do is control them, right? So we've put guardrails up. So you'll see there's this thing called a VM service. What I'm doing here is there's actually 10 classes of VM or sizes of VM that the Kubernetes clusters can use.
Is that
So
like in t-shirt size analogy?
yeah, that's it. Yeah, so it could be 2, could be 5, could be 10. So these are like big, real big, or small. And they might be guaranteed or they might be best effort. So in the development namespace, I might just have like a couple of small VMs that are best effort. Best effort from a ERS, scheduling, HA resource perspective in vCenter, right? So if it goes away, the dev's like stamp, but like maybe it's okay, right? If it's production, maybe I'll guarantee those. Yeah.
Can I ask a VMware question?
Yeah.
If that works for VMware. So in AWS, for instance, you could choose a spot instance which is not guaranteed to run, but it's a lot cheaper than a dedicated EC2 instance or something like that.
Yeah.
How do you associate cost with this? I know it's on-prem, so we kind of throw cost management out the window, but can you put sort of a cost around that lower class of service where you say, look, run if you've got the resources, if you don't run? Otherwise, why wouldn't the dev just say, give me the best one every time?
Yeah, so as an admin or as a platform, like as an infrastructure, you're controlling this, right? You can see in here, like I've created a user called Devops Dan, right? And I've just given that person view access, right? So
This is not staged. This is not staged.
I could give it edit access, right? But I wouldn't give him owner access. So yes, I can definitely govern all the resources he can attach. So he can't like blow up my cluster. I can govern the size of the machines. I can govern like the storage policy. Maybe I've got like really, really super fast SSD, blah, 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 gold storage. But then I've got some like other not so super fast bronze storage, right? I can actually surface them up as policies, storage-based policy management in vSphere, up into here for consumption by devs or app owners or teams, like that, right? So you're very much in control of who can do what to something, right? So it's very, when you think about like adopting Kubernetes or adopting containers in your organization, the ability to use stuff that's familiar, like tooling that's really familiar and consistent, and you've got skills and experience and investments in, it just makes it like a lot easier to get started. And also I mentioned like it's 60 days of having a bit of a play around with it, right? If you're at vSphere 7 level. What else is interesting? I mean, there's a lot more you can see, but I won't go because it's primarily Kubernetes related. So you can see things like persistent volumes. Okay, so we talked about maybe Kubernetes still needs to store state or data somewhere. Very rarely do you get to see them other than the command line, right? So you would usually be hacking away at the command line saying, show me the persistent volumes that I can attach to via claims. But vSphere now can do that for you, right? You can see things like, you can see network stuff related to the CNI. CNI is a container network interface. It's required to do things like east-west for pods. You can see that in vSphere, right? These are things that, just make the whole job really, really easier and the start time a lot lower, right? Otherwise, you'd be interacting at the CLI. So this sort of platform, you have a left and a right, right? So if I'm a developer, I'm still going to be accessing Kubernetes probably via the command line. But if I'm a platform person or an infra person, I'm going to use vSphere because it's familiar to me and we've exposed these types of capabilities for you to take advantage of. Right? Is there any other questions? Is there questions on the vSphere, any of the vSphere stuff? Yeah.
Just regarding Kubernetes, when you enable that Kubernetes thing, did it by default spin 3 VMs or appliances or whatever it is? By default, is it 3 or you just?
Yeah, it's 3 because it's a highly available cluster. Yeah.
Okay. So these are the master nodes.
Yeah. So the supervisor. So if I expand, so in my namespace, you can see this one here. So I have one cluster. So if I expand the development namespace, that's my Kubernetes cluster running in the development namespace. Now, if I had a production namespace, I could have another cluster running in there. I could have 10 or 15 clusters running in development, 3 in production. So it scales like that. Now, the idea of the namespace is to get control, right? To do resource allocation and get control. Now, when you mature from this type of concept, what you can actually do is you can enable people to self-serve, right? So you actually stamp out one of these namespaces as a template. And then the developers or the app teams just consume it on a self-serve. Remember I said that moving to this type of architecture is all about self-serve and frictionless experience and speed, agility.
Does that self-serve go as far as integrating into like VRA and so forth?
Yes.
Because at the moment we do our self-serve through VRA, so
Yeah.
talking VM, not container.
Yeah.
But it's something that we're looking at the moment is extending to, long story short, those that know who we're at know what I'm talking about.
Yeah.
We've got quite a large migration project to get off where we are now onto a new platform.
Yeah.
And we've got quite a significant amount of excess capacity. We want to start potentially doing containerized services internally, but at the moment, our provisioning framework is all through VRA. So we can see if we can replicate that experience.
Yeah.
But for containers instead of, obviously there's obvious differences, but yeah.
Brian, you've got some, a couple of pieces here. One is that some of the developers are often, if they've got tool chain set up, etc., will want to use a CLI to drive straight through at the Kubernetes level. However, a lot of sort of maybe, let's say, somebody DBA or something like that is just driving a database and wants to be able to provision a full database instance. VRA is going to be a far better tool for them to do that. So there's forces.
Yeah, so you can definitely stamp out blueprints like cluster creation blueprints, and then there's another API layer that I can show you how you would get more clever with it as well.
Okay, cool.
I just want to quickly touch on this. This is something we call mission control. This is like a SaaS control plane, which you could conceptually think it sits above the clusters, if you like, right? Now it sits above the clusters that may live in vSphere, but it also sits above the clusters that may be living in cloud, right? So you can see in this tool here, like I have clusters that are in Azure, I have clusters that are in AWS, I have clusters that, here, there, and everywhere, right? So this is like, this tool has an ability to both provision clusters and actually attach existing clusters. So if your business has maybe experimentation or AKS clusters in Azure, whatever it may be, we can bring them in under management, right? So you can actually, drive cluster creation, you can drive policy, you can drive backup and restore and migration activity. You can do like extensions. We can give you extensions to install via this tool here. So this is like, could additionally be a single point of management for not just my vSphere stuff, but maybe in the future, my cloud stuff. And if I've got a single point of enforcement, declaration of policy, and then enforce across my environment, that's pretty interesting. And that gives me, again, consistency, right? And we know that consistency means efficiency and that sort of thing. Yeah, so this is an interesting tool. It's got a lot more capability. I just thought I'd show you because you can actually create the clusters in vSphere from this tool as well. That's probably, I'll probably leave it there. One more thing I'll just quickly show you is that, you know, if you start, you know, setting up vSphere, deploying some clusters, that's awesome, right? That's sort of like, you know, that's a start. But what you want to get to is this concept of, you know, building a platform and treating that platform like a product, right? And when it becomes a product, it's consumable by the rest of the business. So ideally you want that platform or the capability that you've exposed stretching horizontally across your organization. Because then what happens is more people start using it or get interested in using it. And then the business, you know, starts to, you know, maybe do things a little differently, maybe get stuff to market a little quicker, maybe recognizes revenue earlier, lower time to value, all that sort of stuff, right? So when you do that, beyond just Kubernetes, there are other things to think about. You know, what the one that I just showed you, the mission control, is like for cluster management. It's like a management or a control plane. But then you need to be able to see stuff, observe stuff, trace stuff, do root cause analysis right through the stack, right? Because you're talking about a different type of surface now. You're talking about, you know, small things, many things, you know, complicated things. So something like observability tooling. Observability is sort of like a maturity sort of beyond monitoring and logging into something that we call observability. So it just gives us, you know, a holistic view of our stack, you know, from infra up to apps and even things like APIs as well. And then, you know, maybe I've got services running in vSphere, maybe it's a database, maybe it's a middleware thing, and maybe the front end of it runs in AWS, right? Because it's scalable and it makes sense for us to do that. But what if those services are likely need to talk to each other? So how do I secure that service, right? How do I do mutual TLS? How do I just make sure that, you know, it's contained and nobody can get in the middle of it, man in the middle and all that sort of stuff. So maybe we need to start thinking about things like what we call a service mesh, which is just sort of secure service to service communication, right? That sort of thing. So these are other, you know, and obviously load balancing. Load balancing doesn't go away in the container world. In fact, you want it to be even more dynamic, right? Because if I'm a developer and I ask for a service of type load balancer for my app, I don't want to go through a ticketing system to the F5 or to whatever to create me a virtual IP. I want it to happen automatically, right? And through these types of capabilities, it will happen automatically. So that's all I had. Any questions? Everyone keen to get started tomorrow? Or that one person has vSphere 7 maybe to start tomorrow?
So one thing I would call out here is if anyone does want to have a play with any of the Kubernetes pieces, Tanzu Basic, it's free of charge for you to download and play with. So you can find that online, download it, install it in your so thank you, Tanzu Community Edition.
We also have this, which is open source Kubernetes backed by a community, which open source is. A lot of us as well. So this gives you the Kubernetes experience. You can deploy it to your laptop. You can deploy it to cloud. It actually acts like a production cluster, so you can scale it. You can make it like really big. You can scale it back in. It's a fully featured code base. It actually takes all the releases that we do upstream. For commercial editions, it takes them first, right? So if anything, if you use this sort of thing, you're getting like the latest and greatest, if that makes any sense. So it's got really good documentation. It'll tell you how to do it in your laptop, and you can maybe just start to have a bit of a play around. We also have something called Kube Academy, which maybe Ben can distribute, which is just a free learning academy, right? So teaches you.
Which are absolutely brilliant. I really, really recommend it. If you haven't looked at it, it's kube.academy.
That's it.
As a URL. Go on there, set up an account. It's a load of interactive videos led by some really, really good presenters explaining the basics of Kubernetes. And it's just as applicable if you, God forbid anyone would want to, but just as applicable if you're going to run Kubernetes in the cloud with our hyperscaler partners or whether you're going to run native Kubernetes within vSphere. It will give you all those foundational capabilities. So absolutely brilliant tool to start with.
Is that Tensor now, that's what, PC based, is it? Laptop, running off the laptop?
Yes, you can, yeah. If you, if your organization, I mean, if you have Docker desktop, a lot of organizations have Docker desktop, we actually provide it as an extension. So it's basically a single click and you get a cluster. Alternatively, like
Run off the workbench on your PC.
you could run it. You can run it in if you'd like virtualization on your laptop. You can run if you've got a Windows machine. You can use the WSL, the Windows subsystem for Linux, to spawn it. It's multi-deployment targets.
So we're just going to swap over to Patrick, who's going to be 20 minutes or so, half an hour or so, I think. And the pizzas are on their way. So if anyone wants to take a quick intermission, grab yourself refreshments. We will be up and running again in a couple of minutes.
This was the lead in. Hands, guys. Recording. Cool. Yeah, show of hands. Who actually has worked with devs before? Hey, we have a few people. Cool. Because that's what we're basically going to be talking about, right? It's the dev experience and what the DevSecOps pipeline's for. But I guess to give you guys a bit of an idea of what the agenda's like, it's all obviously up there. What I'm going to do is talk a bit about the persona, what they're kind of looking for, what we're kind of helping them do from a platform perspective, and then, give you guys an idea of what it's going to be like when you actually deal with the platform that, Jamie was pretty much talking about, and the layers above. So, fun times. So, devs pretty much, they want stuff that is easy to use, that really requires no more things, because, you look at their jobs titles these days, they're all full stack devs. They're going to learn everything pretty much these days. And that goes to DevOps engineers, that goes to platform engineers, and everything in between, right? You're expected to know a lot these days. So, if we're thinking about platform engineers and platform engineering, realistically, we want to give devs something that they can easily consume so they can really focus on building some apps. Okay? That's essentially what we're doing here. Okay, so when we're talking about platform engineers, it's pretty much what I just said. We want to make it really easy for them to use, potentially cut down on a whole lot of tooling from our point of view as well, if we're platform engineers. Do you guys all know what a platform engineer and DevOps engineer is versus what you're probably doing these days, sort of?
You should.
Okay, all right. How about I explain it? So, from a DevOps perspective, back in the day, I think it was in 2011, there was a summit and they were basically talking about working collaboratively. I can't even say the word. Working together with different teams, right? They were trying to break down silos, and essentially that kind of spawned the term DevOps, right? So what they were trying to do was deliver something and also think about operational concerns in one go. It kind of evolved a whole lot of different methodologies. It evolved a whole lot of processes, and a different mindset and a way of looking at things. I think these days when we talk about DevOps, we're talking about real cultural differences more than actually the technology side of things. So it's like, hey, we have a multidisciplinary team or a cross-functional team, which means we have a whole lot of people in a team that just want to deliver a business outcome, and everyone in the team has all the skills from an infra perspective, from a network, from a security, from a dev, from a testing perspective, that can do everything and deliver a business outcome. So that's pretty much what DevOps is. Now, from a DevOps to a platform side of things, that's a little different. So the mindset back in the day was that DevOps was a bit more ad hoc in the way that it was kind of thought about. Platform engineering is actually stuff that's done at the very start, where you basically build a platform for devs to use. Okay, different from DevOps, where it's just kind of, we kind of need to do it. So that's pretty much the difference between DevOps and platform engineering. So when I'm talking about platform engineers, I'm talking about pretty much kind of almost the next iteration of DevOps. Okay, and what we're eventually going to probably have to do, right? So, it's basically building some of this stuff. And, quite honestly, I don't know about you guys, but hearing Jamie talk, there was a whole lot of stuff there that was really complicated. And, I don't know about you guys, if that all resonated with it's not easy. Not easy at all. And these days, when you're trying to manage something like that, you tend to use a lot of tools to abstract some of the detail to make it easier for yourselves. And that's where a lot of the platform conversation comes in, because you don't want to actually have to do this over and over again. That's also where the continuous delivery pipelines come from, deployment pipelines come from, and DevSecOps pipelines come from. I'll explain a bit more about that as we go. But for now, this is kind of what we're trying to aim for. We're trying to aim for easy way to manage a platform if we're going to build it for the devs. We want to make sure that they actually adopt it, because, if, we build a platform, it's great. But if we don't have a working workload or an app that a developer's built on it, it's pretty much not, there's no value really to it. So it's better if someone's using it, essentially, okay? But from our perspective, we really want to make sure that, we don't have to maintain too much. So again, it's about using some of the tooling out there that you basically stitch on with Kubernetes to make things a lot easier. And when you do stuff like that, you don't necessarily have to treat your platform as a pet versus a cattle. So you heard Jamie talk a bit about that. You essentially want to make sure that, you can basically spin something up, spin something down, and it's a concept called, ephemeral environments. You want to kind of have that mindset in place, because from a business perspective, the costs are actually lower. And from an availability perspective, it's really awesome to be able to spin up a whole nother stack to test a new feature or a little bit of code. So to be able to do that, there's got to be a bit of a shift in the way we treat some of our infra. Okay. Sorry, go on.
I think the pizzas are here, so what I suggest is we'll pause for a couple of seconds.
Cool. You guys can keep. It's all good. I'm not going to look at your faces while you're eating. It's all good. Anyway, essentially going back, so, there's a whole lot of concerns that we'd love to address. I think the last one is the only one that we really wanted to talk about, which was immutable versus mutable things. So essentially, can people change them? Can they not? Effectively, you don't want anyone to change stuff, especially when you're deploying stuff to an environment. That's why we talk about this stuff. When you build a platform, there's a whole lot of different platform concerns that you really want. And one specific one that you really don't want is for people to be able to manually deploy stuff to an environment, because it starts breaking all sorts of stuff. It invalidates a lot of testing, you name it. It's not a good idea. Anyway, out of curiosity, I know I'm talking a whole lot about app devs. What bits are the most interesting for you guys? Because I'm just mindful of time and I can talk for hours on just one slide. And I'm trying to avoid that. So, what are the things that you guys really want to know? So, is it more things around the management concerns of when you actually have a platform? Or is it a case that, you guys are on a journey and you're actually moving to a platform and it's kind of being told to you that you have to build or you have to buy something? There's also even a whole nother kind of huge segue into that if I want to get into it. But what is kind of everyone interested in?
If a line of business came to you and asked you to start to deploy Kubernetes apps, whether they're commercial off the shelves or your developers asked you, would you guys know where to start?
No.
Short of ringing your VMware rep up and screaming help.
Probably do. So quickly, you saw this from Jamie's slides. There are so many open source projects. And yes, there is an appeal to go down the open source path. Honestly, there is, because it's free, right? To a degree it is, because when it comes down to the actual day to operations or the maintenance and support side of things, who has to do it? It's probably all you guys. Secondly, when stuff goes wrong, and it happens a lot in open source, who's actually going to fix this stuff? Who actually has all the knowledge to know in that particular integration for an open source component, what's actually happening there? you're going to have to look at the code and you're going to have to analyze it, understand the issues that are actually already there. And if it's not there, raise one and try and get some support, or fix it yourself by submitting code. Now, those type of options, they're great. Day one, they sound great. But when you get into it and when you do this at scale, it becomes extremely difficult because everyone will need to know the ins and outs of the platform that you're using. Especially if you're running with agile teams and you're running with cross-functional teams, right? Everyone will need to have all these skill sets to look at every part of the platform and know exactly what's going on here, right? To fix the platform problem. And they do occur, especially with open source projects.
Did anyone roll out Openstack? Has anyone ever tried deploying Openstack? Yeah.
Fun.
And Openstack was probably best described to me as a science project without a manual. For anyone that's I did try and deploy it, and Openstack 1/10 of the number of components you see in the CNCF framework. So you can imagine what it's like taking a science project without a manual and making it 100 times worse. That's what you're going to be playing with if you try and deploy Kubernetes from
nothing.
Yeah, effectively.
Yeah, so like even from a recent client experience, I'm talking to a client that wants to build vanilla Kubernetes. And I don't know if anyone's tried or heard horror stories, but I don't think you'll find a very good positive story about that experience, because if you think about what Kubernetes already is and the complexity involved, and then you look at all this other stuff that you'd probably want, which is represented somewhere there, the amount of stuff that you're going to have to integrate yourself is insane. You need to learn that open source technology. You need to know how Kubernetes works. And then you've got to figure it all out and stitch it all together. And I can guarantee you will run into so many compatibility issues. There are so many in open source projects. So you've got to be careful. And I'd personally say that the best way to do this is to go down an opinionated route that a company offers that has enterprise support. That's my personal opinion. I've been down the open source route in a lot of different places. So prior to my working here, I was working in other companies like Woolies X and other stuff. So I've had to run platforms and I kind of understand what that's like. It is fun, but it's also, it can be a nightmare, especially when you get calls at like 3 a.m. So it's like, it's not working. Oh no, what happened? We don't know. There was an update somewhere. It can get like that. So that's why I'd always honestly say, hand on heart, go for something with enterprise support if you can. Okay, and fortunately, or unfortunately, this is a very old diagram as well. It's not a CNCF one. It's from a developer perspective. You get an idea of the complexity that you start dealing with when you're going down the open source route. You got to integrate everything, right? And then you got to constantly maintain it. And then at the same time, devs also have to build a whole lot of stuff, right? So
It's got to be wrong. There's nowhere near enough VMware level.
Oh yeah, no. This is more an open source one, but yeah, a really old dev one. So you get the idea. There is just so much out there, and personally, the best route, always opinionated, because you'll get to know a few tools really deeply. You'll know the pros and the cons of stitching stuff together, and you worry a lot less down the track. Okay. Now, obviously, I covered some of this already, but essentially, when you start looking at all those diagrams, you realize really quickly there's just so much out there. Like, how do you know which one to use? How do you know you're not being lied to in a forum? Like, this vendor's saying it's amazing. Every customer says it's amazing. And then you use, you're like, oh, really? It's not really like that at all. This is painful. So, what we try and do is, again, go down the opinionated route. Yay. This is what this is all about. And these are the things that you probably want to worry about, right? Like, with some of the solutions out there, some of the open source solutions, they automatically update. They automatically upgrade. And for good or for worse, at least it's something that's supported. I can't say that for everything else, especially open source, right? When you look at some of the other platforms out there and some of the tool chains and the technologies involved in them, they scale automatically. That's freaking awesome. You don't have to worry about that stuff, especially if you're running containers, Kubernetes, you're running on the cloud. You can pretty much scale horizontally and not have to think about, oh, do I have to buy more hardware and stuff like that. So Going down an opinionated route is definitely a good idea. There's a whole lot of options out there. I'm going to let you guys decide. I'm not trying to sell you something. I'm just saying, when you do your research, you'll probably end up with one particular platform, and I'm going to get my guy to show it, but it's actually one of the Tensor products. But essentially getting into it, there's just so many concerns that you will, and I guess from an infra and operations perspective, it's 100% going to be the day two support side of things. You know, you're going to need to learn all the skills for all the tool chains, and none of them use probably the same technologies and the same languages. So it's going to be rough if you go down the open source route. So try and steer away from it. Anyway, so the next problem that you also got to think about is, if we have this platform, say you've solved it, right? You either bought it or you built it. Either way, how do you onboard stuff at scale? It's awful. It's hard because you deal with, generally in a really big organization, you're dealing with a lot of different teams, and the teams always, so, you know, some might be really, really far ahead. They might be doing some stuff in the cloud already, but some other teams might just be happy working on-prem and doing stuff there. So how do you actually get people to onboard stuff at scale on a platform? Well, the thing is, it actually comes down to psychology. Actually does. There's an actual, you can look it up on Wikipedia. It's actually called normative social influence. And it's essentially that if you have a lot, like the majority think and do things in a certain way, everyone else in the group, even if they feel differently, will end up doing that.
Yeah.
Okay, so yeah, you've heard of that. And that's probably really applicable everywhere you go, right? So even in your current companies, there are a whole lot of people doing a whole lot of things in a certain way. Guarantee you, it's probably going to end up that way. So now how this relates back to onboarding apps and all that is, you know, through DevOps, it's through continuous delivery and all that type of stuff. We think about this stuff because we want people to work together and adopt a certain way of working that's different, okay? And the way you do that, and I've ripped this from some of the stuff from our department, is how you actually culturally scale and change an organization. So I'm kind of deep diving and going into stuff that you may or may not be interested in, but I guess a lot of it's based off the psychology of the normal, I can't even say my words properly, normative social influence. Okay, but anyway, so the idea is, you know, you start small, you essentially get a smaller amount of people to basically adopt a certain way of doing things, then you scale in this type of way and it'll definitely work. Whereas most people's thinking is that if you're trying to scale a new way of working, you typically have one very good team that does it all, and then you split everyone out. Problem is, when you do that, it's that whole psychological kind of barrier. It all changes everything. That one person who knows everything and has a certain way of working now goes back to the kind of status quo. That's just generally how that works. So really good tip for how to actually try and do cultural change from a DevOps perspective. Now, the other question that I think you'll probably end up asking is, even if you have a platform, even if you have, you know, the cultural change to onboard a whole lot of people, how do we actually get stuff safely to production? You're probably going to end up with a whole lot of issues if stuff doesn't actually get vetted properly and quality assured properly, right? So how do we do that? Well, incoming pipeline, right? And continuous deployment. So do you guys know about continuous delivery and continuous deployment?
Yep.
Awesome. So I don't have to really talk to you about that. There are differences, but essentially there's a slight evolution of that, and it's that rather than fitting in just building and testing and then releasing the software, you want to basically embed security into what you're doing as well. And a lot of that, I mean, you guys probably know this already, but when you're running into security issues, they're usually pretty bad. Like Log4j was a recent one. I know you guys probably all heard about that one. A lot of problems with that. So, you know, embedding security into like a pipeline is going to help you big time, because you're not going to want to do any of this manually. So, you know, if you're setting up vSphere or something, you don't want to just do it once. especially if you're going to run in this type of fashion where it's very iterative. You want to be able to automate a lot of this stuff so it goes through the cycle really quickly and you can keep doing all sorts of amazing things like spin up an entire environment based off a pull request, if you know what that is. But you can essentially do that if you have a DevSecOps pipeline. So what I'll actually do really quickly though, something cool, is show you what a typical pipeline looks like. So let me zoom in. You guys see that? I don't want to take too long on this, but essentially the idea is you write a bit of code, you run a bit of tests locally, you submit it via a Git push, which is like a tool you use to basically manage your source code, right? It triggers a whole lot of stuff, which is essentially the merge of the code into a code base and a release candidate. You do a whole lot of testing and security scanning on it before you build a container essentially. And then you can basically store it somewhere for you to then put it into an environment. But that's after we've provisioned a whole lot of infrastructure, sorted out the network topology and sorted out the security policies, all that type of stuff. So this is pretty typical of a pipeline. Is this kind of familiar with you guys as well? If you guys have done CI/CD pipelines, then this should be pretty straightforward as well. But that's essentially what that is, and that's just something I'm doing for a client right now and working with them to stand up and change a pipeline. But anyway, so you kind of get the idea of this. There's a whole lot of concerns you want to address when you're running a DevSecOps pipeline. A lot of it is probably going to be related to the way you actually use the pipeline. You want to avoid a lot of the manual steps. You want to do everything as code, not just infrastructure as code, but everything as code. And you probably want to use Git to do it. Okay, they're probably the quickest, most cut down way of I can, going through these slides. There's actually only a demo left to show. I know you guys are going to have a ton of questions. You can ask me later, or you can, ask other people in your organization who know a little bit about this stuff. But what I actually want to show you is what I think is a really good option for you guys. And it's essentially a product called Tensor Application Platform, a lot like Tensor Community Edition, where you can actually get it. And it actually has a whole lot of really cool features. Okay, so what I want to do is quickly get Jordan. He's a guy on my team who actually does the work. I just talk about it. But I want to just get him quickly to show you what that's like and actually show you what workload getting pushed onto the cloud. Just keep in mind, a lot of this stuff that we're going to show is it can be pushed anywhere. It can be pushed on-prem as well. This application platform can actually sit on top of any of your cloud providers as well. So if you're using AWS, Azure, or Google, you can definitely use Tensor Application Platform. Okay, so I'm going to quickly let Jordan share. But in the meantime, maybe this is a bit too deep, but this essentially gets into the reference architecture of what TAP looks like. And again, I'm highly recommending this because it is miles ahead of, there actually is no other option in the market right now for this, because it's just so well integrated with a whole lot of open source technologies that are actually supported by VMware. Oh, sorry.
Sorry.
Let me do this.
So I can see it.
Sorry, I forgot to do presentation.
Oh, good.
I stole it. He stole it just stolen it anyway.
Yeah, it doesn't matter.
Oh, good.
He's going to show you some of the cool stuff.
So what? So from a probably more layman's perspective, the way I describe what you're going to see here, build service, is the ability for developers to fling code at the wall and to have that code run. Because the developers really, let's be honest, they don't want to have give a monkeys about how you package workloads into a container. They don't want to have to care about the underlying infrastructure. They don't want to care that, for example, they make calls in their code to Tomcat or to Java or whatever the hell it is. They don't want to have to download that Tomcat or the Java engine, whatever they make a call to. incorporate that, roll it out, etc. They want to just say, make that call an RPC call or make an API call directly to those applications, utilize those applications and have them run. From an operations perspective, you want to make sure that the versions of those applications they're running don't have any vulnerabilities. And if you do have a log4j comes along in a couple of years' time, you want to be able to find where all of those versions of the log4j are in your instance, rip the bastards out as quickly as you can, rotate them, and actually respawn those containers. Remember, containers are ephemeral, so you kill the containers, roll out the new ones to replace them, and as they roll out, they will pull the known good version of those applications from the library, and this is what you'll see here. So what this does is it makes a developer's life easy. And from an operations perspective, if you make a developer's life easy, they're probably going to like you quite a bit.
Yeah, winning. All right, your turn.
Yep. All right, so you saw that stuff about Kubernetes, right? So once you get Kubernetes, what do you actually do? So Tensor application platform requires just a tap values file. You specify your configuration. This is pretty much the vanilla YAML file. Cool, YAML. It's very basic, right? So we don't actually need to configure it much out of the box. So what does this even do? So essentially we have these base plane accelerators. So if I want to just, am I a dev and I want to do Node.js, I want to do Java, it doesn't matter the language. We support a lot of different things with the build packs and deployments. So we can just choose any. In this case, I have chosen a simple Java one.
Is this an image?
So this is just a zip file. I can show you in a sec. So you generate a file based on the parameters. We will put everything together, explore it. So we get a base like folder, or you can just use this as like a Git project base or repo base. And you just give all the specifications you need to start the actual application building. So the big one to actually look at is, so the main code is in here, right? But I pulled it all and pushed it to my repo here. So if you look at the config file, we have a work file, the workload YAML. This is just a small sample of what we actually need. I specify the repo where the code is going to end up. So we only need to deploy this once. We only need to specify here a command called Tensor apps workload apply. Once we create this, we don't need to worry about it ever again because we're using a, let's see. Is my screen big enough?
Yep, just about it.
So we're using this thing called Git repository to actually look at our Git repo and constantly poll it for changes, right? So if there's a new commit or whatnot, it will pull this into our favorite thing, a CI/CD pipeline. So what does the CI/CD pipeline do? Well, we're just creating an image and deploying it, right? We can configure this further with image scanning and build, source builds and source testing, source scanning, all that. But this is just basic, out of the box, basic one. So where we go from here, we have this image, created this. As mentioned before, we're using build packs. It creates, downloads all our needed Maven repositories that we will need for this.
So all your dependencies essentially.
Yeah. So we don't actually care about what the dependencies are. We're grabbing this from Maven. We're building this image, and then we're going to store it in whatever the configured image repository is. If it's Harbor, if it's GCR, if it's ECR, nothing. We don't care. We're just going to store it there. After we build it, we're going to specify the config that needs to be deployed and install that into our namespace in Kubernetes.
See me build it at lunchtime.
Yeah. This was pretty easy. So we have these pods, these build pods that actually what completed and has the images stored in the image repository. We have this service, which is kind of what you can know as a load balancer. It just sends it back to the deployment. The deployment sends it to pods, and then we just kind of configure that. So if we just go to this K-service endpoint, we can see that it has sent to this image. Now, almost if we change that to from hello world to, I guess,
Dinner world.
dinner.
This pipeline is a part of the, means you don't have to build it it's like the tools which you are using here, like Maven you are using, you don't have to deploy it. It's part of your system.
Yeah, so out of the box, we don't need to display. It uses Maven. We can use these things called build packs, right? So these build packs, we already specify where we need to go. So if it's like .NET, we're going to go from the NuGet stuff. If it's like, I guess, Node, we're going to go to npm, grab all that stuff that we need. We don't.
So the best way to think about a build pack is that it's like almost like an extension to Docker. So you'll have, your typical container, but it'll put all your dev tools into there as well. So you don't actually have to worry about it. So from a dev perspective, it's actually quicker to use a build pack than it is to stitch a whole lot of containers together. So that's the reason why we use build packs. At the same time, when there are things that happen from a security perspective, so like, there's a problem with a dependency here, because build packs are managed externally, they'll actually, on day zero when there's a problem, they'll actually update the build pack, so you don't actually have to worry about it.
They update the build pack, or they release a new build pack?
They'll update the build pack, so everyone's just going to have it. Yeah. Right? There you go.
Yeah, so right now, I've changed my code in just the Git repo, and I specified where it was in the code, our workload YAML. So now we just got to wait until the Git repository is picked up. So all I did to install this was the YAML, right? So what does it actually install? It installs a bunch of custom resource objects. So all these things are related purely to, I guess, TAP, which is the application platform, on top of all the native Kubernetes objects like pods.
So just look at that and think about how much you don't have to do. There's a lot in there.
Yeah, and if you want to learn every single one of these, have fun. It's great. Yeah. So we're going to poll again. Still not picking up. Classic.
You should do a live demo. That always works perfectly. Yeah.
It might take a few minutes, but it'll get there.
I suppose whilst we're waiting for this to run through, are there any questions either in the room here, or I know we've got the VMUG down in Melbourne, got a few people down there. Any questions from either in here or Melbourne?
So you're looking at the age there of how long?
Yeah.
Is that telling?
So it will tell you, it usually takes about 3 to 5 minutes, depending on when you start. It's polling every few minutes. So I don't know how long it's going to take. But is there any questions on the TAP stuff?
It's not an event based, basically it's a polling based, right? It's,
Yeah, pretty much. So when we want to scale out to multiple, it's kind of using the GitOps philosophy. So if you know what infrastructure as code is, it's like the next layer on top of that. It's using GitOps is basically just like infrastructure as code, merge request, and CI/CD pipelines. So it kind of, instead of how CI/CD usually approaches things, it pushes has like a service account or some sort of role which gives it permissions to deploy everything they need, but you kind of give it admin or God permissions, and if someone gets handle on whatever they want to do, they can control everything you got in your cluster, right? But the way that it differs kind of between GitOps is you use a pool-based method, so you use polling instead to kind of have different layers of segregation. So you got someone who controls the code, the source code, and you have someone who controls the, I guess, platform or Kubernetes. So you kind of got protection from both sides. Yeah.
Add a -w at the end, just so it'll just refresh as soon as it's there.
Yeah.
Just we got Chris, so team in Melbourne can hear as well.
I just add a -w at the end of that line. You won't have to
Just to watch it.
Yeah, I should. Now we have to wait like.
Yeah, just sit there and watch it.
Or I can just hard.
So that change you've made, that's put it like into a central repository and everyone in the group then sees it.
Yep.
Let's say you don't want everyone in the group to see it quite yet.
Mhm.
Can you have like a hierarchical thing of repositories?
Absolutely. So you have different, like in TAP, we have 3 different like kind of roles. We have the developer, we have the operator, and we have the security team. Right? Security team, who cares about them? So the main developers, they will just.
Anyone trying to deliver something on time compared with
So we have the developers who only care about pushing their code to Git repos, right?
Yeah.
They can manage their controlling there, right? We only need to have TAP able to pull that stuff from that. Then we can have the operators kind of using whatever their configuration they want to, I guess, if they don't even want your code, they can just go, we don't want your code. We're not going to give you permission to pull your Git repo. So guess which layer wants, both teams need to work together in order to get this working. And it still hasn't worked. Yeah, demo failed.
I think we'll take it as
Take it as
take it as written. It works.
Well,
It's just the demo got
Demo
taken
gods
away.
are not my side. I can also just force it to change.
Just do that, yeah.
Okay, so source code name. That's what I want.
So what you're seeing here really is this is the flip side of what we showed you earlier from the vSphere perspective, and was explained that the developers want to see this. This is where the developers live. They want their life simple. They want to see the API. So this is what we would describe as an application up perspective. But an operations team has the tools that they're used to, wants to use those tools. That's the operations down or the infra down perspective. And where the benefit is here is you've got both views. You've got an infra up and an app down, sorry, an app up, infra down perspective. So you've got the tools the infra team are used to running and traditional ops teams, and have got entire processes behind, and yet the developers have grown up using tools like Git, constantly making pull, push requests from their code bases, sharing code through Git, etc. They're used to working that way. So trying to hamstring the developers into one way of working and the operators into a different, they need to meet somewhere in the middle. And this is what these tool sets do. They're complementary to allow an app up, infra down type sort of discussion.
So how this tool can have the visibility of the Tanzu workload management cluster in the vSphere? Do we need to do some integration, deploy the pipeline from here to deploy any workloads over there, or is there?
Oh, sick, yeah. So I can show you this mad Miro board.
Yeah.
That kind of explains to you how we get there.
That's the one.
Yep. So at the heart of things, we're using Cartographer, which is an open source project. And there is a profile
This is a
where
massive board, by the way.
you can actually have multiple configurations of TAP. So we have build, iteration, run, and view. So there's, which kind of just correlates back to what, I guess, open source project you want to install on that cluster, right? So we kind of don't need to have multiple build clusters in your TKGS environment, right? You only need one to build everything. But if you want to have like 1,000 different run clusters, go for it. All you need to do is specify this run, one thing to run everything, right? So all we need to care about is using Flux to get the image and then building it using cloud native runtimes.
Scales really, really well based off this architecture. And it uses a lot of different technologies to help you scale.
So to implement this architecture, how like?
It's not, it actually doesn't take that long.
Okay.
Yeah, it's actually
Really quick. And it's because of the way that they've stitched it all together. They've made it really easy for you to consume.
So if we go back to this TAP values, In this case, I'm just specifying the full profile, which installs everything.
Okay.
In the example here, we're just using this thing called run cluster. So that's only using, I can show you exactly how many.
Once you've got the run cluster in, the run cluster builds everything beneath it, doesn't it?
So run cluster only runs everything.
Yeah,
The
okay.
build cluster will build everything
Sorry,
and
build
grab that image repo from wherever you specify and do everything for you.
So maybe I guess we need to do that one-time setup of doing this integration of deploying this run cluster and build.
Yep.
And then it will be like easy.
Yeah, exactly. So, are you trying to look for it, Jordan?
Yeah, I'm just finding
This has to be done from this tool or from like this to deploy this architecture. Like it has to be done from this Tanzu application.
Using that to show you.
Oh,
For the
okay.
page. So we have a lot of documentation on this. So
okay.
he's just going through it now.
So instead of like, yes, I'm just looking for the, yeah, I can explain kind of after this as well. So
Was there anything else you wanted to go through for me? Because I think we're probably
over time.
yeah,
Sorry, guys.
yeah, so it takes a few minutes to build anyway. So after it builds, it's going to send this image to a repo, and that's going to get pulled down. And there's this last component of the CI pipeline that's not connected, and that's the reason is because it's going to be pulling that image. It's going to be pulling a your image repo, because that's Harbor, that's ECR, whatever. It's going to be also looking at that and seeing if there's an image. So right now it's saying it's unable to resolve because we haven't deployed the hashed image. But yeah, that's kind of everything.
Okay.
Any questions?
There's probably a whole lot of questions.
Yeah.
We're at a tough
We
time.
saw this demo before, like but that was like more from the application side. But we want to see a demo on the infrastructure side. How is there any like online?
Thank you very much, everyone. If there are any questions, I know we've run massively over time. Hopefully it was useful. If there are any questions,
Let me get back to you.
there's a number of the VMware team around. So please grab us whilst we're clearing up. Thank you.
It's a good thing. Yeah, I guess
It's so different from your normal standard CI/CD pipe as well, because it's not, you don't need it to be sequential. It's always